Turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Greetings once again, ladies and gentlemen. This is Retro Ernest of Retro Electrotech. And I want to start by saying, pardon the noise in the background. The heat is running. It's going to be running because it's quite nippy here in the shop today, and Maine is starting to get very, very cold. It's that season. So I'm going to be paying out the nostrils once again for heat. And it's only going to be going up, 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 because that's how it is. And what we have on the bench here is this Sansui, G as in Golf, 8700DB, as in Delta Bravo. And this receiver here steps into the ring at 160 watts per channel into 8 ohms, so it packs a pretty good punch. Also, this is a unit that I've had in the shop for quite some time. I performed an initial evaluation, of course, and I produced a video some time back covering that. And one thing I want to mention about that is sometimes when I perform that preliminary evaluation and you see that on video, that doesn't necessarily mean that I'm going to move straight into the repair work that needs to be performed slash restoration work that needs to be performed. Depending on what's going on in the shop at that time, how loaded down I am, and I am very, very, very loaded down. I have an extensive waiting list, and I'm working on that to try to get that tamed down, but that's going to take some time. That's just the reality of keeping a full-time brick and mortar shop open. I have to keep a steady flow, keep a steady volume of work moving through the shop, and I have to triage between stuff that I need to put on the back burner and stuff that I can get out the door kind of quick so that I can keep things circulating and keep the lights on, keep the shop open. Otherwise, there is going to be no Retro Electro Tech. And so there's a lot of work involved in keeping a shop open, keeping any small business open in this day and age. It's really, really tough. It takes a ton of work. I work my rear end off in this shop, and as much as I would like to have help, well, that's another story. Okay, so I'm going to get into the process, at least up to this point, but just via the preliminary evaluation, I was able to determine that there was indeed some intermittent behavior, signal cutting in and out, noisy controls, a diminished left channel. The unit was very dirty throughout. There were caps that were physically leaking their contents onto the circuit boards, these driver boards here. And as I started getting into examining the power supply boards further, I decided that I wanted to bolster up the power supply of this unit because of signs and symptoms that it was exhibiting, and things just didn't look good. The fact that there were capacitors that were leaking their contents. I knew that there needed to be some focus on the parts of this receiver that are subjected to more work, more load, that undergo more wear and tear electrically speaking. Again, the amp drivers, the power supply boards that are subjected to higher current demands and so forth. And sure enough, as I was recapping the power supply boards, there's this board here, and of course the drivers, and then there's a power supply board on the back, and a protection board and all that. And while I was removing other electrolytics, I found that there was more physical leakage. Again, that's what I did thus far. And one thing I want to mention about that, and let me just kind of change the view a little bit so we're not staring at the same thing. But I recapped the power supply board here. There's a few caps on the protection board here, a few electrolytics that I'm going to change out here in just a bit. I'm going to do that off camera because there's only a few of them, not a big deal. You can see I have the covers pulled from the from the relays. I'm going to be cleaning the relay contacts and all that, and possibly doing a little bit of resurfacing of the relay contacts. They're not too badly pitted, but they need a little bit of freshening up. Other than that, you know, I went in and serviced all the controls. Now, one thing I want to say about that is the controls were in really, really rough shape. And I talk about that often in my videos about the different levels of control servicing. So in a situation where, you know, you're dealing with really rough controls, at the very least, you're going to have to go in and perform a multi-flush servicing. And multi-flush meaning just that. You're going to flush them out multiple times. Now, what is access like? Sometimes you can pop the top off of a piece of equipment, and the ports, meaning these here, if you take a look at this pot, you see that there's a port, an opening on the top there, okay? And there's one on the bottom too in this case. So if you have access ports that are pretty straightforward to get to, then a lot of times all you need to do is carefully drape for drainage purposes, to absorb drainage. Drape the board and just go at it and flush them out. Work the controls over and over and over and over again. And I emphasize that until your wrist is literally hurting, your fingers are hurting. You really want to give a lot of attention to that. Flush them out multiple times, repeat the process. Nothing glamorous, it's just a lot of repetition, a lot of, you know, again, just purging out the controls, flushing out any gunk, and, you know, working the wiper along the resistive track so as to clear a path and break up any, you know, any oxidation, tarnish as much as possible so that you can establish a good connection. Because remember, when you're dealing with bad pots, crusty pots, staticky pots, intermittent pots, it's a connection issue. There's different types of connection problems. Sometimes bad solder joints, sometimes connectors such as these, the type of connectors that, you know, plug into the board, those type of connectors there. So most of the problems that you are dealing with you know, this equipment here sort of revolve around connection issues. There's a lot of that. In fact, when I go in and I recap, you know, the power supply here, I'm going to be pulling this board off next to change those few caps. At the same time, I'm going to be bringing the magnifier so that I could kill two birds with one stone and examine the solder joints the best that I can with the time I have to work with, and reflow solder joints as needed. I have, you know, the soldering iron cooking and ready to go, so I'll touch up and, you know, add a little solder as needed. If it's a real bad solder joint, I'll clear the pad and evacuate the old solder and apply new solder. But if it's not too bad, sometimes I just reflow what is there and add a little bit of solder, just a tiny bit, kind of freshen things up and bolster up the solder joints, things like that. And then I'll go through and thoroughly clean the boards and just re-examine things and just make sure that all the connections are very sound. And even the connectors on there, like in this receiver here, and I'll show you on this board because I'm sure it's the same, where the pins were very oxidized, the pins in the sockets, or excuse me, tarnished. And I'll go a little bit more into that in just a little bit. Let me get these Teslas out of the way. I have this this meter up here because I was going through, and as I was recapping, I was also checking resistor values and just going through, and also too I was checking the junctions of transistors just to make sure that nothing looked odd. There wasn't any open junctions, shorted junctions, which I didn't suspect would be the case here. But I wanted to check everything out, but mainly resistor values. I wanted to find out if everything is within tolerance, because as you can probably tell, this board is discolored. Now I cleaned it up with some anhydrous alcohol, and a brush really went through and cleaned any residual carbon, if you will, You don't want anything accumulating on the board that could become conductive. Same with the backside. I cleaned it up really, really well. In fact, there was discoloration even on the metal chassis behind the board. This power board here gets really hot. You can see the big heat sinks there. But I wanted to be sure when I was going through recapping the board, I wanted to evaluate again all the other components on the board to see if there was a reason why it's getting hotter perhaps than it should. See if there was any resistors that were way out of tolerance. Fortunately, everything looked pretty darn good. Everything was within reasonable ranges of tolerance. This is just a board that gets hot. What I am going to do though is I'm gonna peel the transistors back from their heat sinks, clean up the old heat sink grease and apply new heat sink grease. And like I said, I went through and cleaned the the connectors, all these connectors here plugging into the board. I went in, pulled them off, and got my scratch pin and just kind of buffed out the pins a little bit. Got my little, I have a little set of micro brushes to kind of clean out the sockets and spray a little contact cleaner in there, clean out the sockets. So I do all that I can when I'm in there. So this is a job for the detail-oriented individual. If you're gonna stand out and maintain a good reputation, do professional level work, if you don't share the same view on that, that's fine. But I also have to turn this work out to customers. And that's the way I approach things. And let me back out. Okay, so the point is, we performed thorough servicing on the controls. They responded favorably for the most part, with the exception of some of the push button switches. And I pulled one of them back out, and just to kind of show you what I'm talking about. So they needed deeper servicing, the switches. And sometimes, you can get away with trying to dribble a little bit of contact cleaner on and around the the push button, the plunger section, in the hopes that a little bit of that contact cleaner will permeate, work its way in. But in most cases, if the switch really needs to be serviced at a deeper level, that's not going to do. And these switches weren't really made to open up. So they're sealed switches. So what I ended up having to do, and what's commonly done, is breaching the body of the switch with a little drill bit and drilling into the hollow cavity. You got to be really careful when you do that. And I don't know if you could see here. Let me go ahead and zoom in. Hopefully you'll be able to. Let me spin her around there. Okay. Now hopefully you can see what I'm talking about. These two switches over here were okay. This one was fickle, and there were another handful of switches, that are reinstalled to the control panel there. I just pulled this out to give you an example, but you see the hole that I had to drill in the body here. Okay, and when I say drill, I'm not talking about with a drill motor, like one of these little pin vices, these Archimedes type drills. You can use one of these, and you got to move slow, and at the same time, you want to try to get the hole situated, at the rear of the switch, with the switch in the off position. You don't want the plunger or the switch engaged, because you probably could see you could probably see the okay, if you look at the hole there, you can probably see the switch through that hole engaging. Okay, so you don't want it engaged when you're drilling in through the rear of one of these types of switches. You need it disengaged, and you got to drill in as close to the the end of the switch to the rear as possible, and you move very, very slowly, very gingerly. And while you're working your way through, there's going to be shavings that you want to brush away. You don't want to force any shavings into the hole when you pop through. So I use like one of these blowers, and as I go, as shavings are starting to build up, you know, I'll kind of blow it off. And you could tell when you're getting ready to pop through, because the bit will kind of seize up toward the end just a little bit, and then I just turn it with my fingers the rest of the way, just barely. And when I feel myself kind of pop through, I very carefully pull it out, and you know, make sure that I brush away any shavings. And usually what I try to do, if I have the room, a lot of times it's kind of hard, but you'll notice I have one of these little mini vacuums here. You know, I can kind of pull out a little bit. Let me do that. But what I try to do is, if I can, I try to situate things just so, or if I have an extra set of hands around, I'll have somebody hold the little vacuum nozzle near the you know, near the opening there that I'm going to pop through while I'm pushing the bit through. Just before I'm ready to pop through, I'll kind of try to hold that vacuum nozzle right by the hole. And sometimes I could do this myself, and just with the other hand just kind of twist the bit on through, so that when I kind of pop through, you know, I'll hold the vacuum right on the hole, just in case a little bit of, you know, residual plastic dust or whatever. Most of it I clear away during the process, but that last little tiny bit I try to suck up with a vacuum if I can. If a little tiny shaving of plastic got in there, I've never had a situation where it proved to be enough to seize things up or cause problems with the control, especially once I go in there and start flushing out with you know, contact cleaner, and then reintroducing a little bit of a fader type lubricant. And what I do is, to get the lubricant in there, there's a couple ways you can go about it. You can use one of those bottles. You can put some contact cleaner in one of those squeeze bottles, those little syringe bottles. Or, you know, I rigged up a little straw that I put on the can of contact cleaner, and you can see the little syringe needle that's bent. And, you know, I use that, you know, place it into the hole that I drilled, and inject the contact cleaner in there. Okay, and really flush it in there good, and you know, it really gets in there into the hollow of the cavity there, and floods it, and starts, you know, pouring back out of the front there. And so it does a really good job. So I had to do that to these switches. And sometimes too, and I mention this every once in a while, I've mentioned this in other videos, sometimes too, depending on the type of potentiometer, the type of switch, sometimes it's so bad that when these controls don't respond favorably to a flush style of cleaning like I'm talking about, then it becomes necessary to disassemble, especially potentiometers, and clean them when they're disassembled with you know, swabs and solvent, and then, you know, brush the appropriate lubricant on the track just a little bit, and go in there and do an even better job. But some controls are very, very difficult to disassemble. They are not of the disassemblable variety, so it can be pretty challenging. There's kind of ways around that. There's workarounds that get pretty involved, but unless you're dealing with a very rare control that you're just not going to get, and you can't find a workaround, a suitable substitute, replacement, whatever, then, you know, sometimes you do have to do what you got to do and try to maneuver around the next to impossible. But, you know, it can be done. I've done some pretty interesting things. So I just wanted to touch on that, because this can get rather involved, and that's what I had to do with all the switches. Yeah, well, most of them. There was a few that I didn't have to, that were doing okay, because after we worked on the controls initially, you know, I got a signal into it, put it on the scope, I was testing the controls and all that, and most of the problems that I was getting were in the push button switches, several of them. But the pots seemed to respond favorably. You know, they were a bit fickle before, the potentiometers themselves, are, especially the volume pot and the balance control and all that, but I got that all worked out, and they seem to be working fine now. So let's move on. Okay, so I'm getting ready to work on the protection board now, get these and get these old electrolytics out of here and just go through the board a little bit more. I I had forgot that I needed to take this this power supply board back off. There's only a few screws to kind of maneuver this board. Oops, not a big deal, but I did a little bit more work than I needed to for nothing. I should have just left this board off. But again, no biggie. What I'm going to do for starters is there's a lot of I don't want to bend this board down too much. Right here is about the limit. Good enough for me to get in here and desolder and drop in my new caps, but there's a pretty good layer of dirt kind of caked on there. I'm going to flush the board off. I'm just going to use some, I have a rag in there, as you can see. I'm just going to kind of spray it down with a little bit of anhydrous alcohol and just kind of brush things off a little bit and just kind of clean it up. Plus, you know, I'm going to be cleaning it again to remove all the flux residue when I get the new caps in. I always like to leave the board clean. That's just my thing. You don't necessarily have to do that, but hey, you know. So anyways, that's what I'm going to do. Oh, you know, one thing that I mentioned a little bit ago is the importance of going through and cleaning all the connection points, connectors and whatnot. If I zoom in here, and hopefully you can see, you can probably see how tarnished these pins are on this connector. So as I mentioned before, I use of course, you can use different things. Sometimes I'll use like a little Tarnex or something, or whatever the case, but sometimes I like to go in just with my little scratch pen here, a little fiberglass pen, and just clean off the pins, especially on contacts and pins and all that are large enough to use a scratch pen. I'll go in there and just kind of clean them off real quick. And then the socket itself, I have a little set of, you know, these micro brushes, and I'll just use a little bit of contact cleaner and go into the socket itself, spray a little contact cleaner in there, and just kind of go in there and clean the sockets out and so forth. So you get the point. But you can see how bad these surfaces are as far as tarnish is concerned. So anyways, let me go ahead and get to that, and I'll be back once the board is recapped and so forth. And also, as I mentioned, I'm going to clean the old heatsink grease off of these heat sinks, and you can see it's already getting pretty dry and flaky in there. It's, yeah, this is all flaking off. It's all dried out. So again, I'm just going to use a little bit of alcohol on a swab and just get in there and clean this garbage off on the heat sink and on the back of the transistor. Just get this all cleaned up and then apply some new heatsink grease and get her done, you know. Let's get the back of the transistor there. If I can keep that in frame. You get the point. It's just getting the old stuff off and putting the new stuff on, and I'll apply the new stuff in just a minute here. Okay, let's apply a little bit of heatsink grease here. I'm just using some of this Dow Corning heatsink compound. Again, as I always say, this isn't rocket science, just a thin layer on both sides, and we're in business. I'll get these tightened down and we're ready to go. Move on. Okay, let's go ahead and recap on what's been done. And I'm not talking about capacitors, just recap as far as reviewing what's been done. If you hear some noise in the background, like somebody drilling or something, there's a guy doing some work outside of the shop, a cable guy or whatever. So anyways, I've recapped all the power supply boards. Any of the transistors that were sitting on any type of a heat sink have been cleaned of old heatsink grease. New heatsink compound has been reapplied. All the boards have been cleaned up. I've gone through and checked component values in circuit testing as far as resistors and transistors and all that. Make sure everything's looking okay. Resistors are reading within their specified tolerances and so forth. So I've gone through and done all that I can. The only other thing that I have to do on this board down here is just the relays. I'm going to pull them. I already removed the covers. I'm just going to pull the contacts out and polish them up a little bit. They look pretty good otherwise. They don't look badly pitted or anything. I'm going to examine them a little closer, but that's pretty straightforward. So that's about it there. Okay, so back to the top side here, and just real quick, as I mentioned before, the driver boards have been gone through, new caps, any transistor that's sitting on a heat sink, cleaned of old heatsink compound, new heatsink compound reapplied, went through and in-circuit tested all the various components, resistors and transistors, just kind of spot checked everything. Everything's looking good. Touched up solder joints while I had the boards out. Just kind of clean things up of any excessive flux and dirt and grime and all that stuff. Same thing with the again, the power supply boards, here and up here. All that stuff has been squared away, everything cleaned out. And so I did a lot of stuff, collectively really went in here and gave everything the once over and touched up on all the critical maintenance stuff that should be done and gone through, and attention to detail as far as all that goes. You might notice the filter caps are still in here. I leakage tested them earlier on in the servicing of this receiver. I put voltage into them and leakage tested them, and they were holding up really well. I think they're still pretty solid, so I'm just gonna leave those in place, but recap everything else power supply related and the drivers and all that. Again, right now I'm not going to do a full recap of the tuner board and all the other boards and tone board and all that. That's going to be for a later date if the customer ever wants to do that. But I think right now, budget wise and even the time that I have, because I'm so loaded down with work, that's good. I just want to get the problem resolved as far as intermittent, fickle, staticky, nasty controls, signal dropping out, all those leaking caps that were physically leaking, especially on the driver boards. Then I can concentrate on any little nuances, any little problems, that I might need to hone in on, like if any transistors start getting noisy or anything like that, leaky transistors, any snap, crackle, pop kind of stuff, or anything, any diminished performance because of transistors or anything like that. But as far as I know, everything should be fine there, because again, when I was going through the earlier maintenance, servicing the controls the very first time, I piped a signal in and put this on the scope and was kind of checking things, got a signal in it and was playing around with the controls, and that's why I knew I had to hone in on those switches and go in a little bit deeper there and inject contact cleaner and work them a little bit more, because they were still a little bit fickle. But the point is, when I had a signal in it and I had it on the scope, the signal actually looked pretty good. So other than the relays, polishing up the contacts, the only other thing that I need to do here is, and I'm going to just turn this around real quick, is you can see I have all of the output transistors pulled. And the reason I have them all pulled, of course, is because I'm cleaning everything up, getting all the old heat sink compound off of everything. You can see down here I did the same with the these heat sinks that bolt up against the TO3 package transistors and all this. So I got them all cleaned up. The only thing I have to do though is I do have to clean up the transistors themselves and the mica pads. So once I get them all clean of heatsink compound, then I'm just going to, since I have them out, I'm going to briefly gain and leakage test the transistors. These output transistors don't have to be critically matched or anything, but I just want to check them to make sure they're in the ballpark and make sure there's no excessive leakage or anything like that. And I think they're probably going to be all right. I'm pretty sure anyways, hopefully. And that's that. I think what I'm going to do is come back in just a little bit, and once I get these transistors cleaned, and I'll probably test a few of them on camera and then start applying the heat sink compound back to the heat sinks and the surfaces here on this part of the heat sink area, and then get the transistors mounted back in, get everything bolted back on, and I will be ready for final testing, and we'll go from there. So anyways, I will be back in just a moment. Okay, as I was mentioning a moment ago, I'm going to get into a little bit of down and dirty gain testing and leakage testing with these testers here, and they do a good job for that, just to give you some ballpark readings, measurements. And if you know the limitations of your test equipment, then you know what to expect and what you're going to get out of them. If I wanted to go deeper and I wanted more definitive results, I wanted to examine the characteristic curves of these transistors, and I wanted to really split hairs when it comes to gain matching and what have you, or I want to examine a transistor failure more in depth, then I would use a good curve tracer for that, and get a little bit more deeper into the analysis aspect of that. But these do just fine for what I'm doing. And what I'm going to do, like I said, is on camera I'm just going to check a few of these transistors and compare the readings that I get between the two testers here. So yeah, let me go ahead and set up the camera so you can see the meter panel here, and we'll go from there. Okay, so we're obviously going to start with this tester first. You can see I have the transistor all hooked up. This transistor tester here sorts the pinout for you. The other one here, you have to know the pinout of the transistor and hook up the test leads accordingly. But again, this one sorts that out for you. And anyways, so I'm just going to scroll through a few parameters, not all of them, just the ones that I'm interested in at the moment. And so let me okay, so we have our PNP, and that just shows us our pinout and all that. Current gain of 43. Okay, and then let me just scroll down to leakage. Okay, so according to this tester, it's bare bones minimum as far as the leakage goes. And again, the accuracy of this type of tester, it's not bad. Okay, it definitely gets us in the ballpark, like I already said. So let me go ahead and move on to the next one, and we'll do a comparison. Just remember the gain, and it was what, 43. Let's see how the other one compares. Okay, so we're all hooked up to this tester, and what we have to do is just select the transistor type. We know we're reading a PNP, so let me go ahead and move this control over from off to PNP. Okay, and then the needle's deflecting. We need to kind of zero it out here, or calibrate it close enough. Now I have the little switch here set to ×10, and this is our test button. So I'm going to go ahead and see what we've got. So we're in the ballpark of about maybe 46 or somewhere around there, close enough. And the other tester gave us an indication of about 43-ish. So they agree with each other close enough. Now, as far as leakage is concerned, this knob here will show me collector to emitter leakage over here, and we want it down there at the bottom, as close to 0 or nothingness as possible. Now for our collector to base leakage. Okay, so down there at the bottom where we want it. And there you have it. So let me do one more transistor real quick, and that'll be it. Okay, and I have another PNP from the batch hooked up. Let's go ahead and see see what we got here. Okay, we have a gain of 53. Let's scroll down to our leakage. And minimal there. So we're looking good. Our last one was 43, this one was 53. You're going to get readings like that with these output transistors, and you know they're going to differ a bit, but as long as they're not way out of the ballpark. And let's go ahead and check though on this tester here to see if they jive with one another. Okay, we're all hooked up. Let me go ahead and switch this over to PNP. Dial it in just a little bit, calibrate it. Good enough, times 10. And so we're showing just about 60, okay? So the other tester was showing what, about 53. This one about 60. So again, they're not far off. They're again in the ballpark. And if you know the differences between your testers and what to expect, the limitations of these testers, then you know what you're going to get. I'm in the ballpark. That's good enough. Let's just look at leakage real quick. Okay, we're down at the bottom there for collector to emitter leakage, collector to base leakage. Okay, so everything's looking good. I'm happy with that. And as long as I'm in those ballparks for what I'm trying to accomplish here, and that's good enough. So what I'm going to do is go through the rest of them off camera, and then I'm going to get the heat sink compound reapplied and get these things back in. So I'll be back in just a moment. Okay, as you can see, and I'll zoom in just a little bit here, all of the transistors are back in place except for one up at the top. You'll notice the heat sink compound applied to, you know, these surfaces, okay, that are going to mate up with these sections of heat sink. Now, if I go back over here and kind of zoom in a little bit more, you'll see that the heat sink compound is applied, you know, thin but even. And it doesn't have to be perfect, okay? Some people get really hung up on that sort of thing. In all honesty, it's not a work of art or anything. When these sections here are bolted back together, okay, the heatsink compound is going to kind of smush, if you will, and even out nicely under the pressure of the two surfaces coming together and being bolted in place. So not a big deal. You know, don't get too hung up on that. Those of you that are applying heatsink compound, the main thing is that you apply a thin yet even layer, and just even enough, just so there's no you know, big missing patches, or it's all blotchy or whatever. Because again, when you put everything together, like for example, I applied a thin even layer here. When I lay the piece of mica back on there and I kind of apply a little bit of pressure, you'll see what I mean. You know, it spreads out nice and even, okay? And let me get back in frame here, that would help. But it's nice and even under that mica spacer, and I'm going to do the same thing. I'm going to get my brush and apply another thin and even layer, and by the time I mount this transistor back to the heat sink, it's going to spread out nice and even once again, and provide nice thermal coupling and, you know, transfer, heat dissipation, and all that stuff the way that it's supposed to. So let me get this last transistor back in place, and then I'm going to go into some testing, get a signal in it, and go from there. So I'll be back with that. This is going to be a longer video. As you can see, I have the receiver back on the main bench here. If I zoom into the scope, of course I have a signal fed into the unit, the DUT, device under test, and I'm getting out a nice symmetrical signal on both channels. I didn't have that before, but we're looking good now. I've gone through all the controls, which I'm not going to do on camera in the interest of time, and I just don't want to bore everybody to death. This video is getting long, and everything's looking good. All of the controls are behaving as they should. I'm not getting any more jittery behavior, any noise or intermittency. Those switches that I drilled out very carefully and worked on a little bit more in depth by injecting contact cleaner, copiously, and working the switches thoroughly over and over again and so forth, straightened out the problem. I suspected that would be the case. So everything is looking good. Also too, what helped things out was the recapping, obviously. The power supply is all bolstered up now with good electrolytics. Those driver boards that had those leaking caps are all squared away. All the connections are looking good. Solder joints, again, all the pin and socket connectors and all the stuff that I named. Everything's looking good. So I'm going to go ahead and get a little audio test going. I'm going to move this over to the other bench. Oh, you know what? Before I do transition on over to the audio test, let me go ahead and see what we're putting out in terms of power. All right, so let me bring it up to pre-clipping. Okay, there's a little asymmetrical clipping there on one channel, but we're still getting about 165 watts per channel into 8 ohms. Looking good. And can things be improved a little more? Certainly. If I was to go in, I had a little bit more time, budget to go through and work on the rest, and just go through and dot the I's and cross the T's and really just fine tune everything, then yeah, I could definitely improve things. But considering where this was when I first took it in, we have drastic improvement. I'm sure it's going to perform well during our audio test. Oh, and another thing too is that I will recheck the biasing on it. I did that the first time around and got everything dialed in pretty darn good. But I'll check it again and just make sure that everything is still in the ballpark, where I left it the first time. And if I have to tweak a little bit, fine. I know DC offset was looking good first time around. I tweaked everything. So anyways, let's get to some audio testing. Okay, and here she is, cleaned up very nicely. I detailed the faceplate, knobs, everything, get all the crust off. And yeah, it seems to be doing okay. Like I said, I'm going to be monitoring it here in the shop for a number of days. I just want to be sure that everything's going to be working okay. I'm going to be, poking around with the controls and that's it. Anyways, I have it on the tuner right now. I'm just going to turn it up briefly because of the whole copyright situation and all that. So let me just do that, give you an idea that it's functioning. Okay, so that's that. And then let me, I do have some YouTube music on the CD, so that should be okay. Let me turn that on. Let me see. Okay, so it seems to be doing just fine. As I mentioned before, this unit could definitely benefit from more work down the road. When I get things leveled off more and, if the customer wants to bring it back down the road to have the other sections recapped, I'll be able to get to it a lot quicker at that time. The first time around, I just had too much going on, but, I was able to get to it, obviously. But anyways, that's that. I'm just going to leave the video here, and there's plenty more stuff that's coming to the bench as soon as I can roll a little bit more video footage in between all the work I have to do. So as I always say, guys, peace, love, music, and the vintage audio that brings it to your ears. Till next time.
This is a poor man's shoe production.